So this is the part 2. So we learned in the previous part about precessional angular motion, and you also learned about what is angular velocity of precession and axis of precession, okay, and precessional angular motion. So today for this session we will learn about what is gyroscopic couple, and after this we will go for some problems, okay, in the next session. So it's important to understand what is gyroscopic couple. So I'm just going to take a coordinate system. We have the x-axis, y-axis and z. Okay. About the x-axis, I have my disk which is rotating in anti-clockwise direction. Alright. So the OX will be known as the axis of spin. So this was taught last class. Okay. Now direction of viewing is in this direction towards x. Alright. So if this is the axis of spin, OY becomes the axis of precession. Why? Because axis of spin rotates about axis of precession. Okay. So this disk, if it's rotating and it moves at an angle d theta on the plane x, o, z, that is the horizontal plane. Okay, on the plane, horizontal plane, it rotates d theta, and at an rotates at d theta, it will reach the position OX1. Okay, so this particular disk is actually, axis of spin is rotating about OY. So OY becomes axis of precession, and the plane perpendicular to OY on which the disk rotates, that plane is called as plane of precession, XOZ, which is the horizontal plane. Alright, now this disk is rotating on this plane. So this plane and Z, OY, okay, in other words YOZ is parallel. So this YOZ is called as plane of spinning. Okay, it's known as plane of spinning. These are the terminologies that we'll be using. So plane of precession, plane of spinning, axis of precession, axis of spin. Okay, so now this creates, now if we, in the previous class we saw the vector OX dash. So x dash, if theta t is really small, x dash will be perpendicular to the axis of spin. Alright, so this creates, so x dash will be known as the active gyro couple. Alright, this is the change in angular motion, change in momentum, and we learned in the previous class that what is gyroscopic acceleration, angular acceleration alpha c. Okay, so angular acceleration of theta, change in angular velocity in time dt, that is x dash. So if this is really small, this x dash will be perpendicular to the axis of spin. So we can also take this active gyro couple. So we can take OZ as the axis of active gyroscopic couple, and the plane perpendicular to OZ will become the plane of active gyroscopic couple. Alright, so here there is a couple, since there is a movement here x dash, there will be a couple applied on the disk causing the precession. So there is going to be a reactive gyroscopic couple. Okay, so this couple I omega p. I is mass moment of inertia of the disk about OX. Omega is angular velocity. Angular momentum of the disk. Angular momentum of the disk is I omega, and the couple created, that is x dash, is I omega p. So this x dash is known as active gyroscopal, and a reactive gyro couple will be created in the opposite direction. Alright, so here omega p is nothing but d theta by dt, which we have already learned in the previous class, angular velocity of precession. So basically gyroscopic couple is applied through bearings which supports the shaft. So basic principle is probably installed in aeroplanes or ships in order to just minimize the rolling and pitching of the waves in terms of ship. So ships, because of the waves, it goes up and down, so it reduces or minimizes the rolling of the ship as well as the pitching of the ship due to the waves. Okay, similarly, it can also be installed in aeroplanes to maintain stability, monorail cars, as well as gyro compasses. So, gyroscopic couple is basically generated when a disc rotates in anti-clockwise direction or any clockwise direction about an axis, and this axis of spin rotates at an angle. And if there is if this precision movement is available, there will be a gyroscopic couple which will be reactive gyroscopic couple which will be generated. Okay, so with this we complete the introduction on gyroscopic couple.